Okay, we talked about the 4 steps of doing a hypothesis test. So we said step 1, the question, right? State the question. Step 2, you have to define the y and the x, okay, or x's. Step 3, you have to get the data. Okay, step 4, what type of data? Okay, so it's data type that is going to dictate the hypothesis test. So let's draw out a table here and let's look at our options. Okay, so let's do the y and the x, and let's do continuous and discrete, okay, and continuous and discrete. So we have a continuous y and a continuous x, okay, put that down here as well if that's helpful. That was the example in the earlier module on does profitability affect or is gross margin a predictor of profitability? Is the number of calories a day that you eat a predictor of your weight? Okay, so weight is continuous, calories, which is your x, is continuous. Your finger comes here. Graphically, you can do your scatter plots, all right, and then this is where you would get into your regression, okay. And then if you had more than one, well, actually, if you have 5 or more x's in Minitab, you would do stepwise. But stepwise regression is when you have multiple x's. Used to be called multiple regression back in the day, but this will do it a lot faster for you, okay? Now, we talked about number of glasses per wine, of wine a day that I drink. But let's say I only drink 1 or 2 or 3 glasses. Well, then that is a discrete x, 1 or 2 or 3, okay? So I have a continuous y, my weight, number of glasses of wine per day is discrete. I end up in this corner. You could also look at your weight by color of wine that was drank. So I could do red wine or white wine. So we've got t-tests, ANOVA, we've got the non-parametrics, which are comparisons of medians. Okay, non-parametrics, they basically can do the t-tests and the ANOVAs for you. And of course, you've got your box plots, which are your graphs. So for example, this would say that regardless of white or red wine, my weight looks to be the same. Okay, and of course, there's lots of other things you can do in here. You can do histograms. I'm just giving you some of the basics. All right, so now I have a discrete y and a discrete x. This is most of your social justice stuff. Is a certain race or ethnicity more prone to prostate cancer? So we often hear that African American men have a higher rate of prostate cancer. So we would have race, I'm using color here, Asian American, Latino, and then we'd have a prostate cancer diagnosis, yes or no. Okay, so discrete y, discrete x. Here's another example, 65%, so we've got male, female. 65% of college degrees go to women now, only 35% go to men. However, it's about 50.5. Men make up 49.5% of the population, women make up 50%. So is this a disproportionately high amount, or are college degrees even among the genders? Okay, so male, female is discrete, college degree probability is discrete, and so compared to what it should be, so this is a goodness of fit test. So all of these are called chi-squared, okay? And you can remember the famous country song that wrote this. It was called chi-squared. Terrible. And up here is r-squared, so that was the B-side to that song. But I like to joke that chi-squared is the test that you do in a nice country voice. So chi-squared, and then of course this would be your Pareto. Your Pareto area would be a place that you could show that. And then lastly, down here, you've got a discrete Y. So that would be pass-fail of a product. So for example, I have a client that makes something for your eye, and they make a sample of 100, and then they see how many failed. So if 2 failed, that means 98 were good and 2 were bad. So the Y is discrete. And then they look at it maybe by temperature or maybe by time. Those are continuous. All right, and so this is going to be your logistic regressions. Your logistic regressions. And you've got, I'll just come up here, you've got binary logistic regression, which is 2 categories, you know, male, female, cat, dog. This is where the term non-binary comes from, meaning not fitting in one of the 2 categories, which means, whoever says that, you are talking about nominal. Nominal logistic regression, that simply means more than 2 categories. Maybe, you know, type of cat, for example, nominal. Now, nominal assumes that one isn't better than the other. You just have more than 2 categories. And then you have ordinal. And ordinal is where one is better than another. This is often a scale of 1 to 5 on a survey. By the way, this is a big mistake a lot of companies make. They calculate the average of a survey score. Let me show you that classic mistake. Here you go. Lee, this hotel got an average of 3.25 on the customer satisfaction surveys. You don't calculate the average of discrete data. In that example, I went and got the data for that location, and it looked like that. And basically, you're misleading yourself by calculating the average. You have a bunch of people that are upset with this location and a bunch of people that like this location. So that's actually ordinal data. So anyway, just builds off of what I told you yesterday. State the question you want to answer. So let's make one up. I'm 245 pounds, so I immediately know that my Y is continuous. Okay? And that's going to be pounds. My X is going to be number of calories per day, so that's continuous. Okay, and I'm going to be up here in the regression, and that would look like this. We would say weight is, you know, 250. I wish I was, I wish I was lower. And let's say calories are 1,000 and 4,000. And of course, you know, you might not want something like that, but that's what the science says, that as calories go up, weight went up. All right, so just a very simple table. In my opinion, this is the 10% of statistics. Now, believe me, there's some advanced theories out there. You could do design of experiments and all sorts of stuff. But I gotta tell you, this is the 10% of statistics that do 90% of the work when it comes to management consulting and problem solving in day-to-day operations in companies. So, hope you enjoy.